Any rare metal chemical element of high economic value that occurs naturally is a precious metal. Chemically, the precious metals tend to be less reactive than most elements. Usually, they are ductile and have a high luster. Precious metals have historically been important as currency, but they are now considered primarily as investment and industrial commodities. Although gold and silver have industrial uses in art, jewelry, and coinage, they are better known for their uses. Without any further ado, let's begin with a list of 15 most precious metals in the world. But before we proceed, it'd be nice if you subscribe to our channel and press the notification bell so that you don't miss out on our future videos. Okay, starting with number 15, Mercury. Mercury, commonly referred to as quicksilver, is a heavy silvery D-block element. It is the only metallic element that is liquid under standard temperature and pressure conditions. The only other element that is liquid under these conditions is the bromine of halogen. Although metals such as cesium, gallium, and rubidium melt just above the room temperature, mercury occurs mostly as cinnabar, that is mercuric sulfide, in deposits worldwide. By grinding natural cinnabar or synthetic mercuric sulfide, the red pigment vermilion is obtained. Number 14. Bismuth. Bismuth is a pentavalent post-transition metal that has chemical properties similar to its lighter arsenic and antimony homologues and one of the nitrogens. Elemental bismuth can occur naturally, although important commercial ores are formed by its sulfide and oxide. The free element is as dense as lead at 86%. When it's freshly produced, it's a brittle metal with a silvery white color, but oxidation on the surface can give it a pink tinge. Bismuth is the most naturally diamagnetic element, having one of the lowest thermal conductivity values among metals. Number 13. Tellurium. Tellurium is a chemical element that is brittle, mildly toxic, rare, and is a silvery white metalloid. Tellurium is chemically associated with selenium and sulfur, all three of which are chalcogens. It is sometimes found as elemental crystals in a native form. It is much more common in the universe as a whole than on Earth. Its extreme rarity in the Earth's crust is comparable to that of platinum. It is due in part to the formation of a volatile hydride that caused tellurium to be lost as a gas during Earth's hot nebular formation. Another reason is its low affinity for oxygen that causes it to bind preferentially to other chalcophills and dense minerals that sink into the core. Number 12. Gallium. Gallium is slightly blue in its solid state. However, it becomes silvery white in its liquid state. Gallium is soft enough to be cut with shears, but if too much force is applied, it may break conchoidally. It has similarities with the group's other metals like aluminium, indium, and thallium. Gallium does not occur in nature as a free element, but is found in trace amounts in zinc ores and bauxite as gallium-3 compounds. Elemental gallium is a liquid at temperatures above 29.76 degrees Celsius, which is above room temperature, but below normal body temperature of 37 degrees Celsius, and for the same reason, the metal melts in the hands of a person. Number 11. Indium. Indium is the softest metal that is not regarded as an alkali metal. It's a silvery white metal that looks like tin. It is a post-transition metal that constitutes 0.21 parts of the Earth's crust per million. The melting point of indium is higher than sodium and gallium, but is lower than lithium and tin. Indium is chemically similar to gallium and thallium, and if we talk about it in terms of its properties, it is largely intermediate between the two. Number 10. Silver. Silver is a soft, white, lustrous transition metal that displays the highest electrical conductivity, thermal conductivity, and reflectivity of any metal. In the crust of the Earth, the metal is found in the pure free elemental form as an alloy of gold and other metals, and in minerals such as argenite and chlorargite. Most silver is manufactured as a byproduct of refining copper, gold, lead, and zinc. Number 9. Beryllium. Beryllium is a relatively rare metal in the universe that usually occurs as a spalling product of larger atomic nuclei colliding with cosmic rays. Beryllium is depleted within the cores of stars as it is fused and creates larger elements. It is a divalent element that naturally occurs only in combination with other mineral elements. Important gemstones that contain beryllium are beryl and chrysoberyl. It is a steel grey, strong, lightweight, and fragile alkaline earth metal as a free element. Number 8. Germanium. Germanium in the carbon group is a lustrous, hard brittle, grayish-white metalloid, chemically similar to silicon and tin in its group neighbors. Pure germanium is a semiconductor with a silicon-like appearance. Like silicon, germanium naturally reacts with oxygen in nature and forms complexes. Number 7. Ruthenium. Ruthenium is a chemical element which is a rare transition metal that belongs to the periodic table's platinum group. Like the other metals in the platinum group, ruthenium is inert to most other chemicals. Most ruthenium that's produced is used in electrical contacts and thick film resistors, in platinum alloys and a catalyst for chemistry. There is a minor application for ruthenium. A new application of ruthenium for extreme ultraviolet photomask is like a capping layer. It is generally found in ores in the Ural Mountains and North and South America with other platinum group metals. Also found in pentlandite extracted from Sudbury, Ontario, and pyroxenite deposits in South Africa. They are in small but commercially important quantities. Number 6. Rhenium. Rhenium is a silvery grey, heavy, third-row transition metal. It is one of the rarest elements in the Earth's crust with an estimated average concentration of 1 part per billion. It has the third highest melting point of any element at 5903 Kelvin and the second highest boiling point. Rhenium is chemically similar to manganese and technetium and is mainly obtained as a byproduct of molybdenum and copper ores extraction and refinement. Rhenium has a wide range of oxidation states in its compounds ranging from -1 to +7. Number 5. Osmium. Osmium falls in the platinum group, which is a hard, brittle, bluish-white transition metal found in alloys, mostly in platinum ores, as a trace element. Osmium is the most dense natural element. Manufacturers use their alloys to make fountain pen nib tipping and other applications that require extreme durability and hardness with platinum, iridium, and other platinum group metals. The abundance of the element in the crust of the earth is among the rarest. Number 4. Palladium. Palladium is a rare and lustrous silvery white metal that was discovered by William Hyde Wollaston in 1803. He named it after the asteroid Pallas, named after the Greek goddess Athena's epithet, which she had acquired when she slew Pallas. Palladium, platinum, rhodium, ruthenium, iridium, and osmium form a group of elements called PGMs. Their chemical properties are similar, but palladium has the lowest melting point and is the least dense of them. Number 3. Gold. Gold is one of the naturally occurring higher atomic number elements. It is a bright, silvery reddish yellow dense soft malevolent and ductile metal in its purest form. Chemically, gold is a metal of transition and an element of group 11. Number 2. Platinum. Platinum is a chemical element which is a ductile, dense, malleable, highly unreactive, precious, silver-white transition metal. Its name comes from the Spanish platinum term, which means little silver. Platinum is a member of the elements platinum group and group 10 of the elements periodic table. It has 6 isotopes that occur naturally. It is one of Earth's rarest elements. Number 1. Rhodium. Rhodium is a transition metal that is rare, silver-white, hard, corrosion resistant, and chemically inert. It is a noble metal and a platinum group member. It has only one isotope that occurs naturally. Naturally occurring rhodium is usually found in minerals like bovite and rhodplumsite as a free metal, alloyed with similar metals, and rarely as a chemical compound. It is one of the most rare and valuable metals. So which of these metals do you like the most for their uses? Do let us know in the comments. And make sure to subscribe to our channel and press the notification bell. That's all in this video, and I will see you in the next one.